Most of the activities we engage in every day involve moving things. To move an object, a force, a push or a pull, must be applied to it. The stronger the force, the farther and faster an object will move. The focus of inquiry for this lesson is, what is a force and how can a force be measured? In Activity 1, Measuring Force, students make a device for measuring the strength of a push or a pull, called a push-pull meter. This activity will take about one 45-minute session. The vocabulary introduced in this activity is force. For this activity, you will need for each team of 2 students brass fasteners, plastic rings, a push-pull meter frame, and a small rubber band. And for the class, you're going to need a spring scale, string, and a bag of toys that we provided in the kit. In addition to the kit materials, you're going to need to supply several medium-sized paperback books, dual-scale rulers, blunt-tip scissors, rinsed soda cans, and full soda cans. You will also need to make a copy of Activity Sheet 1, Parts A and B for each student. It can be difficult for some students to construct the push-pull meter and or tie the string around the paperback books. It might be easier to do these tasks ahead of time. Kathy, let's put together a push-pull meter.
Sure.
The first thing you're going to need to do is to take one of each of these brads and put them in the hole that are drilled out for the push-pull meter. Open them in the back. You might want to leave a little bit of ease there. Okay? Great. Now what we're going to need to do is to take tape and go ahead and anchor the opening of that brad down for safety's sake. Good. Next, take one side of the rubber band and loop it around the brad. Okay. Now when you pull it, twist it. Great. And then anchor it around the other side of the brad. And now we have a push-pull meter. The next thing you'll need to do is to take the string and pull out a length of string that's large enough to go around the book and tie it just like you were tying a package. All right. Okay. You want to leave just a little bit of freedom for the of string. Great. One other thing you'll probably want to consider is to take the spring scale, and what you're going to want to do is to be sure that it reads 0 so that no force has already been applied. Okay? We use force to get things to move. Well, what do you think happens to objects when you increase the amount of force applied to them? Okay, Kathy, let's see what happens when a little force and a greater amount of force, and it goes farther. So the greater the force, the farther the object would move. However, what if this car were a real car? And you ask the students, what if this were a real car? Would you be able to push it with just one finger?
Of course not.
No, and I think students would realize that when something is larger and heavier, a greater force is used to push or pull. Next thing you're going to do then is you're going to distribute these toys, and you're going to give each student the Activity Sheet 1, Part A. And then the teacher places one toy around to each group of 4. The students will record on the activity sheet what they do to get the toy to work. Then they redistribute the toys to each group of 4. Next, the teacher points out that a tool, a spring scale, can be used to measure the amount of force to lift, pull, an object. The teacher demonstrates by putting the spring scale around the book and how it can measure force. Kathy, how much force does it take to lift this book?
Looks like it's a little over 1 Newton.
Good for you. Now, let's take the spring scale and see how much force is used to pull the book.
Oh, just a little over 0, about 1/10.
Okay. All right. At this point, the teacher is going to be introducing the push-pull meter, which they're going to be using to measure pushes and pulls. Teacher distributes 1 meter to each team of 2 students, and then the teacher explains how the push-pull meter will work. Kathy, I'd like for you to push on the rubber band and push to 2. Now push to 4. Now push to 6. Okay? One way that students can measure exactly is to use the rulers. Okay? So that the ruler would stop to measure how many units of force are used. Now, Kathy, let's try pulling. 2 units, 4 units, 6 units. Talk to me about the force that was used to pull the rubber band, these units.
Well, it wasn't too hard to go to the 2 units, but it got harder and harder to pull it the further away I got.
Okay. In this part of the activity, the students are going to use their push-pull meters to see how much force it takes to push something, pull something, or lift something. In this part, we have an empty soda can and a full soda can. Kathy, why don't you show us what the students are going to do as they investigate the amount of force it takes to push the soda can, an empty soda can.
Okay, I want to keep this pretty level, evenly spaced from the table, and give a push. And I see that I've barely registers.
Encourage the students to move the can smoothly, okay? Let's compare that to a full soda can.
Okay, and I see that that almost takes a half of a unit.
Okay. There you have an activity sheet. They're going to record the data on this activity sheet about the amount of force it took to push the empty and the full soda can. The next thing, we're going to use another common object found in the classroom, and that is how much force it would take to lift a pair of scissors. So this time it's going to be lift. So first of all, they're going to take one of those rings that they have and put it around the scissors handle and the other part over the rubber band. Now, Kathy, let's see how much force it takes to lift the pair of scissors.
And so it takes barely any force. It doesn't really register.
Oh, okay. All right. Do you think if the scissors were heavier that it might be more force?
I think we might want to try a bigger pair of scissors.
All right, that would be a good thing for kids to try. The last thing we're going to look at is we're going to take this book that we put the string around and we're going to push, pull, and lift the book. First of all, the students need to put this book kind of at the edge of the table and push the book and record the amount of force it takes to push the book. Okay? Now, I wonder if it would be different if they, in the amount of force, if they attach the ring and pull the book. Okay? All right, got to start at 0 there. Okay. And they're going to record the amount of force it takes to pull the book. Now, let's take a look at how much force it takes to lift the book. Okay. There we go.
Oh, Johanna, it takes a lot more force to lift the book. It's almost reached 1 unit.
Oh, wow. Okay. After the students have collected the data on the amount of push, pull, or lift, the amount of force it takes to move these objects, there are some questions for discussion that the students are going to respond to. For example, which object took the most force to move? Does it take more force to push an object or pull an object? And or does it take more force to pick up an object or slide it across the desk? Students will conclude that it takes more force to pick up an object than to push or pull. The final step of this lesson, the students are going to investigate if it takes more force to lift an object higher off the table. First of all, Kathy, I'm going to, and the students will do this on their activity sheet as well, we're going to lift the book 1 inch off the table.
Looks like it's about 2 units of force.
Okay, let's go up 6 inches off the table.
Yes, it still looks like it's about 2 units of force.
12 inches off the table.
And it's still 2 units of force.
The students should conclude that it doesn't matter how high you lift the object off the table, the amount of force will still be the same. At the end of the activity, collect the push-pull meters and the toys. Leave the push-pull meters together because they'll be using those in a later activity. Don't forget to recycle the empty soda cans. At the end of Activity 1, guide the students in reading What is Force? On page 2 of the Delta Science Reader.